Hello and welcome everybody. This is Forbidden Soul. We're going to be doing a tutorial series on scripting programmable blocks in Space Engineers. So when you script in the programmable block in Space Engineers, everything's done in C#. So it's a good idea to have some knowledge of coding. This tutorial series is going to assume you don't have any knowledge at all. I'm going to try and go through the basics of fields, methods, stuff like that, like for the very basics of programming for you. But it is a good idea to get some type of base understanding of coding in general, object-oriented coding, or C# specifically. So you can check out some other tutorials if you want to get started with that. So you can code directly in game. However, you won't have access to things like autocomplete and code suggestions and stuff like that. So what I'm going to recommend to make life a whole lot easier is to get an integrated development environment, or IDE. On this tutorial series, we're going to be using Visual Studio Community. It's free to use for non-commercial use. You can get it from this webpage here. You just go ahead and click the download button. It will start a download. I've already have it installed. And once that's installed, or while you're installing, it's going to ask you for the features that you want to include. Which I'm going to modify here. And you need to make sure that you have checked .NET desktop developments checked, and that's all you need to code with Space Engineer script. So that will install the packages you need for .NET development, and you can go ahead and continue with the install from there. Something that's also going to make your life a whole lot easier is the MDK2 Malware Devs Kit, second edition, I guess. It's a package that's been made specifically for space engineers that sets things up and makes life a whole lot simpler for getting our scripts in game. Don't let the name scare you or anything. It's not malware. It's just the guy's name. And he's done an excellent job of making life a whole lot easier for us. So I recommend you read the Getting Started with the MDK Hub, which you can access from this link here. We'll go here and it'll tell us to go to our release page, which is here. Download the Win setup if you're on Windows or Linux. I don't think there's a Mac version, unfortunately. I guess Space Engineers doesn't run on Mac, and then we can go ahead and download that. And once you've installed that, we'll have access to the MDK Hub. You can open it up. I had some issues the first time I installed it. This wasn't appearing. I just closed it and reopened it and reloaded everything I needed. So if you're having any issues, just close it down and open it back up again. And then from here, we can create a new programmable block script. We'll go ahead and create a new one. We'll call this tutorial project. Actually, we're going to call this intro project. We're going to have many tutorial projects. Intro project, we'll create it there. And I'm just going to leave the settings for default, but I do like to put minify to full when I'm actually doing a release. Everything else is okay with default settings. We're going to go ahead and hit save. Then we can open in our IDE. And we want to select Visual Studio, which we have installed always. Open up program.cs. It's our main file here on the right. And you'll see that it's populated a bunch of using directives, which gives us all access to all the code suggestions and IntelliSense and stuff like that. And it's giving us a base program here, which has our program, our save, and our main functions that we override all set up for you. So if you're new to programming, I guess the first thing I should explain to you is scope. You'll notice this is namespace in-game script, and then it's got this little squiggly bracket here. So this is within our namespace scope. So anything that's got the thing namespace, anything in here is going to be accessible by namespace. Then we have another public partial class program, and then this :mygrid program. This means public, anyone can access it. A partial class means that it's a class that can get split up into multiple parts. So we could have another C# file down here that also uses a partial class program, and we'll merge the two together when we're done programming. That's a C#, maybe not specific, but a feature of C#. This says that it's going to inherit from my grid program. So all classes can be inherited. This means that this program is a MyGrid program. So it does everything MyGrid program can do, plus what we add to it. So like it has the program method, the save method, and the main method. That's all from MyGrid program, stuff that it has already implemented, and then we can extend it with our own code there. So we'll notice that we have squiggly brackets here as well. That notes the program scope here. So we can always pass down into here. So anything that has a namespace ingrained script, anything that's a part of that scope, we can pass down into our program class. However, we can't pass up program into our namespace. Similarly, we have program here with it, which is the function program, which is inside of our program class. We can pass stuff in this scope down into it, but we can't pass it back up or parallel. So for an example, we're going to declare a variable, and all the variables in C# require a type. So a basic type is called a string. We're going to give it a name. We'll call it display text. And we're going to set it equal to quotation mark hello world. Like it. So a string is a data type that can hold a bunch of characters. A string like this, so like any amount of text you want to put in there, that's what a string holds. We also have data types like integers, which we can say num1, and we can say it's equal to 10. We can't say it's equal to 10.2. Integers don't take decimals; they're just whole numbers that range from -2 billion and something to +2 billion and something. Those are some basic data types. I'll introduce you to each different data type as we use them. So like I said, we can pass this down. So you notice that in program, we can change display text here is equal to new text. We have no problem doing that. We can also do in the save function, display text is equal to save text. Oops. I have no problem doing it there. However, if we declare a variable within inside of our program here, string program text, well, let's say this is new hello world. We can only use it within the scope. We can't go back up and get in a save. If I try and do anything with program text over here, unless if there's no IntelliSense, and I can't set it equal to, like, test. It's red squiggly here, and it says the name program text does not exist in the current context. So that's because we can't go back up. We can pass down, but we can't go up. So that's the basic of scope within object-oriented programming. I'll just get rid of this here. So next we're going to take a look at this public program. I was calling this a method before. Technically, it's a constructor. Anything with the same any method that has the same name as our class is considered a constructor, and that's what it runs every time a new object is created. So every time we create a new instance of our program, or in this case, once we run the script in game, it's going to run all the code within our constructor here. So this is a good place to initialize variables or other things like that, stuff like that. You can also pass in, if this were not an in-game script, you could pass in some parameters you need. So say we need a string, intro, intro text. You could say we need a string of name intro text, and then when we call this constructor from somewhere else, we have to pass in the string intro text, and we can do something with that that variable there. Next up, we have this save method. We're going to skip over this for tutorial 1. We'll get into that in a later video. But this is if we need to save data, like to be persistent across restarts. It's a good place to do it there. So we'll cover that in a later video, like I said. Then we have our main function. This is what gets called every time you actually run the programmable block. So this will get called once you update your script. Like you put your script on the block, it will run that once. And then this gets run every time you run the block or every time you loop it. And you notice it has passing parameters, a string, argument, and an update type. This is a type of, it's called an enumerator, or enumeration, which is just enum. So we can declare an enum, and we'll call this test enum, and squiggly brackets, and it's just a list of possibilities that it can be. So we can have possibility 1, possibility 2, possibility 3, whatever. So it's just like states you could do. So a better example is like days of the week. You could have Monday, Tuesday, Wednesday, Thursday, Friday, right? Saturday, Sunday. Like those are the 7 possibilities it could be. It can only be one of those 7. So it's just a way of denoting things here. So this is an enum of update type. So if we look at update type here, update type, you'll notice that we have IGC, mod, none, once, script, terminal, trigger, update 1, update 10, update 100. Those are all the possibilities for the update type. So every time this runs, it's going to give us the argument that was passed in when we ran it, which is what you type in game. So we can do stuff with that. And then how it was updated. Whether that was whatever the update source was, so we can do some things with that. All right, so next up, we're going to actually have to enable in-game scripting in game. If you haven't done that already, we need to go to options, go to game, and enable experimental mode. You have to make sure that's checked, and it will give you a warning. Just accept the warning. So once it's on there, we can actually use the experimental mode features, which in-game scripts is a part of. Next, we'll have to actually enable them for the world you're playing, so you can go to your load game. You can click on this thing, you can edit settings, game mode, autosave max, advanced tab, and experimental settings, enable in-game scripts. Now we can actually use scripts in our game here. Load in. While it's loading, we'll jump back to some code and let you know what we're actually going to do today. Alright, so what we're going to be doing is something very basic. We're going to be changing some display text around. We're going to do a hello world. We're going to do that, have it display whatever argument you pass in here. It's going to put it up on the screen for us. And then we're going to have it so that it loops around and actually types out character by character different display text, and that will give you the basics of accessing some blocks and changing stuff around. And then in other tutorials, we'll get into some more advanced stuff. So the first thing we're going to do is we're going to declare what's called the global variable, because it's in our program class and it's global to all the methods within it. So we're going to once again declare a string display text, and we're going to set this to hello world. My typing's not so great tonight. Hello world. In our program block, we can access a property called me. So me. This refers to the programmable block, like me, myself, you know, what you're actually coding with. So this means the programmable block that the script is on. And then we can get a surface. So we can call it get surface function, which will run that, and it takes in an integer. So you can do surface 0 or 1. 0 being the top screen of the programmable block, 1 being the bottom screen of the programmable block. We're going to say 0. And we're going to write text, display text. So that means when it starts up, we'll change it around. So this is just our basic thing here. Now, because we have the MDK toolkit installed, all we have to do to get this in game now, and just to test it out, is go to build solution, or Control-Shift-B. It'll run for a little bit here. And we should get a pop-up. If our project has been deployed, yeah. Got our script little pop-up from the MDK hub. All right. So now if we go into our spatial engineers, we can go over to our programmable block here. We can access the control panel. Scroll down until we get to edit. Actually, first of all, we have to actually change this display to be, where's this setting? Content. We want text and images. There we go. Have to change it to text and images or we can't display the text. So we can do that programmatically too, but we'll just do it manually for now. So scroll down to edit. You can go browse scripts and it will open up your workshop. And you'll notice that our programmable block script intro project is right here. There's a couple of scripts I have, but the intro project we made is automatically updated into our Steam workshop. So we can just copy that to editor. And you'll notice that our whole code is right here for us. And we just click OK. And you notice it says hello world now. All right, jumping back to the code now. All right, so next up, we're going to introduce you to the grid terminal system. So that's a property that you can call the grid terminal system. And that's basically accessing, it's as if you open up the terminal like in game, but through code. So anything that it can access, you can access. So the first thing we're going to look at is getting blocks. So first of all, we have to declare a variable that's going to store the blocks we're going to get. So we're going to make this, we'll declare it up here. This is going to be a list, and a list is a collection. As you can imagine, it's just a list of things. So you can have like 1, 2, 3, 4. You can add to the list. You can take away from the list. You can clear the list. You can sort the list. You can do all kinds of different things to a list. So a lot of the data types start with I, my, and then we're going to get a terminal block, which is like it's a block in general. So I, my terminal block, and we're going to call this LCDs. LCDs, yeah, we'll just call it like that, and we'll make it to a new list of I, my terminal block. Okay. So now that we have that in there, we can go to our grid terminal system. And we're going to get blocks of type. I should mention we're going to put a triangle bracket here, and anytime we put these triangle brackets after something like this, it's denoting a type. So lists have types. So this is a list of I, my terminal block, but we can also have a list of strings, a list of integers, a list of any data type. But you have to specify the type within these brackets. So we're going to get a block of type here, and this is going to be an I, my text panel, I believe. And then we're going to pass in the LCDs there. Now we're also going to do a lambda function, which is denoted by, first we have to, so what the lambda function is going to do is it's going to run through every object within this list. So we're going to declare something, so we're going to call this LCD, and we're going to put equals arrow. That means that for each individual, like when we're running through this, an individual LCD, we want to apply a certain filter to it. So in this case, we want to say that LCD dot custom name, or custom name contains, and we're going to look for the tag. We'll call this tutorial. Name's a custom tag tutorial. So that just means that like we'll filter this object here. When we're looking for LCDs, it's going to be filtered for anything with the custom name that contains this tutorial tag here. So when we actually go and name our LCDs in the game, we'll have to tag it with this, and it will only have blocks of that type there. All right, so next we're going to need a now my text panel that we can actually manipulate, that we want to reference my text panel directly. So we'll call this display panel, and we'll leave that undeclared. And then we want to set this display panel equal to, we're going to go to LCDs dot first or default. So it's going to be our first one or default, which will be null if there's no what's going on here? Oh, and we need to cast this. So because the LCDs are an on my terminal block, that's a generic block. But we're looking specifically for on my text panel. And when we did this get blocks of type, we know that they're all text panels, so it's safe to do a cast. And a cast is when you transform one object into another. So for example, you can take a string or an integer and you can transform it into a string. So if we did like, you wanted to print something out, you could say like the number 10 is equal to, when it gets cast to a string, it's this 10 in quotation marks, right? So like 10 can go into a string. It's also a number. However, you can't cast a string. Like we can't say hello. We can't turn that back into a number because hello isn't a number. It's like what the hell's going on, right? So you can't always cast both ways, but you can transform different objects into different objects here. So to do this, you put two braces like that, and this is an on my text panel. So again, the first or default, which will be the first one we find, or null, as a text panel. So now we have a display panel that we can actually work with. Next, we actually want to do something with the display panel. In this case, we're going to output the argument we have to the screen. We're going to go display panel write text, and we're going to pass in our argument string. So whatever we passed into our programmable block here. Whoops. Argument. There we go. Our argument string. All right, and I actually want to do a check. It's if display panel so this is the first time we use an if statement, but we say if and then some condition within this bracket. So in this case, the display panel is not equal to null, it will run the code within inside these brackets here. So if it's not null, then we write the text to the panel there. All right, something we're also going to do here is I said we could programmatically change things to display text and images. We're just going to make sure that every time we run this, it's displaying text and images, so you can actually see it, so you don't have to go in and change it manually. So we're going to go to our display panel and change the content type, and we're going to set this equal to content type enum, and we're going to change that to content type.text and image. So that will set it to have text and images, and then we can actually write the text. So we'll just be working out of the box there. All right, so we'll go ahead and build our project, and we'll jump back into Space Engineers. Open up the programmable block, go down to Edit, browse our scripts, load in the new intro project, copy the editor, okay. Then I need to change the name to have our tutorial tag like we set it up, so tutorial. There. And now if we go to the programmable block and we put in the argument hello world and we hit run, we get hello world on our LCD screen. And you notice that if we go back into here, we can run some other cool text and run some other cool text appears. So this is actually taking in the argument that we passed in and outputting that to the LCD screen anytime we pass in this command. And if we go blank, we can blank the screen out. So programmatically change what's on screen. Thanks. Cool. All right, next up, back to the code. Next up, we're going to have this type out our text letter by letter onto the screen. And the way we're going to do that is have this program loop. And you can set the loop by adjusting the update frequency. So in our program initialization, we can set the update frequency here, or runtime, sorry. Go to our runtime, change the update frequency, and we'll set that to update frequency. We have update 1, which is every tick, update 10 every 10 ticks, or update 100 every 100 ticks. It could be ticks or milliseconds, I'm not quite sure, but I'm pretty sure it's ticks. So every time the game loops is a tick. Tick-tock, you know, like a little clock going on there. So we're going to need to change some of the code down here. We no longer want to write this argument to the text. We want to dynamically change it. So like I said, we have this update source that's going to come through. So basically when we run this in the terminal or from like a control seat or a cockpit or something like that, if you have a trigger set up, we want to check to see if our update source is equal to update type terminal. So if we've done this in the terminal, and then the symbol for OR is 2 pipes like this, that means OR if our update source is equal to update type. What's trigger? We want to do some code within here. So if basically what we want to do here is we want to set our display text to, display text, which we already declared up here as hello world. Our display text gets set equal to argument. So we'll store the value of argument every time we run in the terminal, update that. So that's the text we want to display. We're also going to declare another global variable I for integer. And we're just going to set that equal to 0. This is going to be our count. And every time we run this, we're just going to reset that. Reset I equal to 0 every time we run through here. That's all we need to do. And if it's not, we can do an else if, which means that if it's not true, so if this condition fails, so if it is not a terminal update or a trigger update, else if some other condition, we say the update source is equal to update type update 100. So this means that if it's part of our loop, it's looping through our code here. We're going to take our display panel. We're going to write some text. And we're going to take our display text. And we're going to take a substring of that, which means we're going to take a chunk out of it. We're going to start at position 0. And we're going to go all the way up to position I. So the first time it loops, it's going to go from 0 to 0. So it'll just be the first character in the string. And then the second time it loops, well, actually, we need to give me a second here. So then we want to say if I is less than our display text dot length. So if I is less than our length, then we're going to create I plus plus. I plus plus just means it takes I and adds 1 to it every time. So if we haven't gotten to the end of the string, we increase it. If we're at the end of the string, we just leave it where it is, as what it's saying. So the first time it runs, it's going to go from 0 to 0. Then we're not at the end. Hopefully it's more than one character. So yeah, it goes from 0 to 1, and then I goes up to 1, so then it goes from 0 to 1, so that will be character 0, character 1 gets printed, and then I goes up to 2, goes 0, 1, 2, and then 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5 gets printed. So it should print these out as it loops. Just like character by character across the screen. Alright, so I hope everything's going to work here. We're just going to go ahead and build solution. We'll hop back into Space Engineers. Go to a programmable block. Down to edit. Browser scripts. Programmable script. Copy to editor. Make sure it's got our new stuff. Yeah, it does. Okay. And now we're going to put in the argument hello world here. And when we hit run, well, so it types out every 100 ticks the new letter. It's a little bit slow. Maybe we should have done 10 ticks. Hello, WORLD. Man, that's slow. I thought I had an exclamation point. We can also put down like a command seed here, and we can get inside of it. If we go to G, we can drag a programmable block. Actually, let me get out of here for a second. I just want to change the orientation of this thing. Have it face the screen. There we go. We take our programmable block, and we're going to run. And this is going to be from control seat. That's the argument we want to pass in. Then type. And then we can do another one. Run with no argument. And we'll call that clear. And then if we run this, press 1, we'll get from control seat eventually. Just press 2 and it clears it out. So that's the basics of scripting with Space Engineers. We've gone through how to actually declare some variables, how to acquire blocks with tags so we can get our block that has a custom tutorial tag. We've gone through how to set up the text on this. We've gone through the looping system here using our runtime update frequency. So we do this every 100 ticks. Maybe we can set this to every 10 ticks and then update frequency back to 10. We'll save that. So that'll be a little bit quicker that way. Just demonstrate that really quick. I just want to show you the cool things. Edit scripts. There we go. That's a little more. What kind of jumps and does that from there? Clear it. I don't know why it's jumping there, but anyways. So we've covered the basics. We've gone through acquiring blocks, putting the screen, and handling the update loops. So these are all principles that we're going to use in future tutorials. And it's just the basics to get you started. So I hope you guys found this helpful. I appreciate you tuning in and watching. Hit a like, subscribe if you want to. And I'll see you guys in the next tutorial. Thank you so much.